By 2030, self-driving cars are projected to represent a $60 billion industry. But here is the part that nobody is talking about: we are already years behind schedule, and the gap between the promise and the reality is wider than most people realize. Every major automaker, every tech giant, every venture capitalist told us fully autonomous vehicles were 5 years away, and they have been saying that for the last 15 years. In the next 10 minutes, you are going to discover exactly where autonomous vehicle technology stands right now, what the real timeline looks like based on actual engineering progress rather than marketing promises, and the one challenge that keeps getting ignored in mainstream coverage, the challenge that may ultimately determine whether true full autonomy ever reaches your driveway at all. Stay with us, because what is coming will completely reshape how you think about self-driving cars. To understand where we are going, you need to understand where this technology came from. The concept of autonomous vehicles is not new. General Motors imagined self-driving cars at the 1939 World's Fair in a futuristic exhibit called Futurama. In the 1980s, Carnegie Mellon University built early prototype systems that could navigate roads using cameras and rudimentary computing power. But the modern era of autonomous vehicles truly launched in 2004 with DARPA's Grand Challenge, a race across the Mojave Desert where robot vehicles competed for $1 million prize. Not a single vehicle finished that year. The best performance was just 7 miles before failure. 1 year later, 5 vehicles completed the course. The pace of progress seemed breathtaking, and an entire industry began building around that optimism. Google launched its self-driving car project in 2009, which later became Waymo. Tesla began integrating autopilot in 2015. Uber launched its autonomous vehicle division. Ford, GM, BMW, and virtually every major automaker announced aggressive autonomy programs. The promise was simple and seductive: within a decade, you would summon a car, climb in, and read a book while it navigated traffic perfectly. Here is something most people still do not understand. Autonomous vehicles are classified on a scale from level 0 to level 5. Level 0 means no automation at all. Level 1 includes basic driver assistance like cruise control. Level 2 means partial automation where the car can steer and accelerate but the driver must remain attentive. Level 3 allows the car to handle most driving tasks but requires human takeover in certain situations. Level 4 means the car is fully autonomous within specific geographic areas or conditions. Level 5 represents full autonomy anywhere, anytime, under any conditions, with no human intervention required whatsoever. Right now, in 2024, the vast majority of consumer vehicles operate at Level 2. A handful of highly limited commercial deployments operate at Level 4 in geofenced urban areas. Level 5 does not exist anywhere on the planet outside of controlled laboratory environments. This is not pessimism. This is engineering reality, and understanding that gap is essential to evaluating everything the industry tells you. Waymo is currently the industry leader in actual real-world deployment. Operating in Phoenix, San Francisco, and expanding to additional cities, Waymo's robotaxi service has accumulated over 20 million fully driverless miles. That sounds impressive. And it is. But those operations are confined to carefully mapped urban zones where Waymo's systems have been trained extensively. The company spends enormous resources on high-definition mapping before entering any new territory. That process does not scale easily to a planet with 40 million miles of road. Tesla takes a radically different approach. Rather than geofencing and HD mapping, Tesla relies on a neural network trained by data collected from its entire fleet of customer vehicles. Every Tesla on the road is constantly sending data back to improve the system. Tesla's full self-driving software has made significant progress, but despite its name, full self-driving still requires an attentive human driver ready to intervene. Regulators have scrutinized this marketing language intensely, and investigations into accidents involving FSD remain ongoing. But here is what nobody talks about. The single biggest barrier to autonomous vehicles is not the technology. It is not the sensors, the cameras, the radar, or even the computing power. The biggest barrier is something called the edge case problem, and it is more profound than almost any mainstream coverage acknowledges. An edge case in autonomous driving is an unexpected situation the system has never encountered before. Humans handle edge cases instinctively using common sense, intuition, and contextual reasoning developed over decades of lived experience. A child chasing a ball into the street. A construction worker waving vehicles around a pothole in an unusual pattern. A flooding road that looks passable but is not. A sheet of ice that exists only on one lane of the highway. These scenarios happen every single day across millions of road miles. For a human driver, they are manageable. For an autonomous system, each one represents a potential catastrophic failure point. The mathematics of edge cases are brutal. Researchers estimate there are effectively billions of unique driving scenarios when you account for every combination of weather, road condition, traffic pattern, and unexpected event. Training a system to handle all of them requires either experiencing them all, which takes decades, or building an artificial intelligence capable of true reasoning and generalization. That second option is, essentially, asking for artificial general intelligence, and that remains one of the most difficult unsolved problems in all of computer science. The regulatory landscape adds another massive layer of complexity. In the United States alone, autonomous vehicle regulations vary dramatically from state to state. California has strict testing and reporting requirements. Some states have almost no framework at all. Federally, the National Highway Traffic Safety Administration is still developing comprehensive autonomous vehicle policy. Globally, the fragmentation is even more extreme. Europe, China, Japan, and emerging markets all approach regulation differently, meaning a system approved for deployment in one country may be completely illegal in another. This regulatory patchwork creates a chicken and egg dilemma. Companies need real-world miles to improve their systems. Regulators need safety data before approving real-world deployment. The result is a slow, grinding process that frustrates engineers and investors alike. Liability is another question the industry has still not fully resolved. When a fully autonomous vehicle causes an accident, who is responsible? The passenger? The manufacturer? The software developer? The company that maintained the vehicle? Traditional automotive insurance is built around human driver error. That entire framework must be reconstructed from scratch for autonomous vehicles, and insurance companies, lawyers, and legislators are moving at a speed that makes even regulators look fast. Now let us talk realistic timelines, because the optimism of the 2010s has given way to something more grounded and more honest. Most credible analysts now project that Level 4 autonomy in commercial robotaxi and freight applications will expand meaningfully between 2025 and 2030 in major urban centers. Autonomous trucking on highway routes, which is actually an easier problem than urban driving, may see wider deployment by 2027 in specific corridors. Companies like Aurora, Kodiak Robotics, and TuSimple have been working specifically on this segment. Level 5 full autonomy for personal consumer vehicles is now being discussed in timeframes stretching to 2035 and beyond by the most serious engineering voices in the field. The 2025 promises of the early 2010s have been replaced by 2040 projections. And some researchers argue that without a fundamental breakthrough in artificial intelligence architecture, Level 5 may remain permanently out of reach. What does this mean for you as a driver, a consumer, and as someone watching the automotive industry transform in real time? It means the transition will be gradual, uneven, and geography dependent. If you live in a large, well-mapped urban area, you may be riding in a fully autonomous robotaxi within 3 to 5 years. If you live in a rural or suburban area with complex, unmapped roads and unpredictable conditions, full autonomy may be a decade or more away in your daily life. The technology will not arrive everywhere at once. It will arrive in patches, and those patches will follow economic incentives first. The economic stakes are extraordinary. McKinsey estimates that autonomous vehicles could create up to $4 trillion in annual value globally by 2035 through reduced accidents, improved logistics efficiency, and new mobility services. Roughly 1.35 million people die in road accidents every year worldwide. Before you go, if you learned something valuable today, hit that like button right now. Subscribe to AutoVision Daily for a brand new video every single day. We will see you in the next one.